Exercise 114. Let's first put a remark. So following the discussion last time. So here we have natural topology. This induces B-drum plus natural topology. And this natural topology so induces exactly the product topology on WR, which means the basis of the open intersected with WR gives the basis of the open for the product topology of WR. Wow, something to remark. So let me just mention this is actually a proposition. For the homomorphism theta drum plus from B drum to CK, so this is actually the map modulo the maximal idea. During this section, let's call it small s from CK to B drum plus. Which is homomorphism of rings such that, so important thing, this is homomorphism. This is actually what we have proved. If you remember, not for this, for R we have proved. So recall that we have proved similar thing. For the theta from R to K bar, we have proved that there exists a section ring homomorphism, right? So this ring homomorphism that is theta composed as its identity on CK. Remark 2.1. The section S is not unique. The proof is non-trivial and uses external choice. And there is no such S which is either continuous for the natural topology or a section that is GK equivariant. 2.2. If you consider K bar inside CK, there exists a unique continuous homomorphism. Okay, bar to p1 plus commuting with the GK action. Such that theta composes as its identity on K bar. So this plus exercise 113, also 112, which tells you that if there is a lifting, implies that we can view this theta from B Duran plus 2 CK as a homomorphism, of K bar algebras. Three by a theorem of Cormet. K bar is dense inside P1. For which topology? For the subspace topology. Induced by the natural topology P1 plus the important thing is that this subspace topology on K bar is not its valuation topology. So this in contrast with the fact that for K0 it is the valuation topology, the subspace topology, and for K prime over K0 with, this is what we proved, finite ramification index. It is also the valuation topology that is the subspace topology. Okay, now let's start something new. Let's talk about the element, famous element T. Remark 3. We can construct an explicit element of P1 which we will call it T, and we'll see why we want this element, because this element would later generate the maximal ideal of P1 plus. So this is another generator of the ideal generated by C. So recall that we have proved epsilon in R, which is 1, fifth root of 1. Is a unit because the unit is consists of those whose epsilon 0 is unit, and then Taschen derivative is -1 in WR. Is in the kernel. Recall that because this is just epsilon 0 minus 1, which is 0 by the formula of zeta. Okay, this is the kernel of zeta. Which is field 1 b-dram. So here field I of b-dram is defined to be Ci b-dram when I different from 0, and when I equals 0, this is b-dram. And so this in particular implies that -1 to the power n plus 1 derivative to epsilon minus 1 to the power n over n is here. So this is the DVR is maximal ideal P, and then we work P. This is a field, and then this is in the ideal kernel zeta, so it's in the kernel zeta to the power n. I mean, surely modulo P, this is isomorphic to KR, but R is not a field, right? And I would rather say this is a discrete valuation ring with residue field frank R. Right. What I'm thinking is, can you say divided by n is still there? I'm not sure about this. But one thing we could say that the following construction is well defined, so we're going to define our t to be log of e in the sense of 1 plus epsilon minus 1 because this is in the kernel. And so following power series converges. So how could I show this? Let me think. Let me think. Yeah, actually there is no problem because at least we have this. We have a unique section which we have a section of of the so this is a complete valuation field with residue function bar. This is not discrete valuation, and we have a section as this particular embeds k bar into k, and in particular we could embed wk bar into w of r, and in this w of k bar already we have all those, at least Zp is already there. After invert p, qp is already there. Right. And so in particular this 1 over n, there is no problem. No problem with that. Okay. So the main exercise for today. Prove that the element small t we just constructed contains in field 1 bit-around, but not in field 2 bit-around. Equivalently, this T generates maximal ideal of bit-around. Which means you just consider the ideal generated by this. So this is contained in C, but not contained in C squared. So this is non-zero. And all the ideals are powers of C. And so this must be C itself. Okay, so we'll have to prove this fact that it's contained in field 1 but not in field 2. So since we have the Schmider lift epsilon minus the power n divided by n, in field 1 bit-around for every n bigger or equal than 1, we have as result those power series which happens in that ideal and converges is also contained there. So somehow we use the fact that this filtration should be closed. Yeah, closed sub ring for under the natural topology. And we have proved that actually. We have mentioned at least all those mi gives a closed subring. Also, notice that this is contained in field 2 for similar reason, but only when n bigger equal than 2. So this is subgroup, submodule, so it suffices to show that this epsilon minus 1 is not contained in field 2 bit RAM. Okay, I could have to add the sub exercise to do, but maybe let's continue with this. So the fact that by our computation this is the kernel of theta imply that there exists some element in WR such that epsilon minus 1 equals lambda times C, because C is the generator. And now this is not in field 2 if and only if this is not 0. In other words, lambda is not generated in the ideal C. So if epsilon minus 1 is not in ideal generated by C square, or in other words, it suffices that it suffices to show this is not in C square. So we prove by contradiction. Assume this is I still use lambda for when there is no confusion for simplicity. Let's suppose this is again lambda C squared for some lambda. Then we can write more precisely. We write lambda to be lambda 0, lambda 1, etc. And recall that this C is omega 1, 0, 0. And so at least this C square would start with omega square, and then we don't care. Therefore, this multiplication equals at least lambda 0 omega square at the beginning. On the other hand, This epsilon minus 1 is starting with epsilon minus 1. This is epsilon 0. This is 1, 0. And so just comparing the two, the force is lambda 0 times omega square equals epsilon minus 1. Now let's compute the valuation of this to see whether there are some contradiction. And compute the valuation of this. And this is, so at least bigger or equal than 0, and this is 1, so the valuation of its square is 2 times so it's bigger or equal than 2. Wow. Valuation of epsilon minus 1 is p over p minus 1. And this will be less than 2 when p is not 2. Hence we are done when p is not 2. We have proved t is not in field 2 of B drum. So how about p equals 2? Then in this case this c square would be omega bar square 0, and for any lambda w of r, we have lambda c square equals compute the first two terms. However, when p equals 2, we have minus 1 equals 1. I'm a little confused. Anyway, let me set this as a sub-exercise. Check that in this case, when p equals 2, epsilon minus 1 become epsilon minus 1, epsilon minus 1, etc. So this implies that epsilon minus 1 equals lambda 1 omega bar cube, sorry, to the power of 4 for some lambda 1 from WR, and then again compute the valuation. But then this is a contradiction. So this should come from the fact that minus 1 so equals 1 1 W of F2. The fact is that the hint for this is that minus 1 is congruent to 1 plus 2 times 1 mod 4. This is still epsilon 0 everywhere, but when you use the polynomial validation, you will see that epsilon minus 1 appears also on the second position. So maybe let's recall the formula there. Remember, for the summation of x0, x1, y1, y0, y1, this is actually given by s1 given by x1 plus y1 and then when p equals 2, this is minus 1 over 2 times C21 x0 to the power 1 times y0 to the power 1 plus 1 over 2, and that's the only term actually, yeah. And so this gives you minus epsilon, but 1 minus epsilon is also the same as epsilon minus 1 because this is characteristic 2. And so indeed you have this. I'll just give you checking on second term. Remark. Firstly, note that this t equals logarithm of epsilon depends on our choice of epsilon. In other words, depends on the choice of primitive p power nth roots of unity. So if we make another choice, then this would be the power of the previous one with a unique element in Zp star, which means on each truncation position its element in Z quotient Z to the power n star. Now by the continuity, of the tensor-mirror map. The continuity of the tensor-mirror map with respect to bar-algebras topology R and the weak topology on WR. We have tensor-mirror lift epsilon prime equals tensor-mirror lift epsilon to the power a WR, and thus take the logarithm. T prime is logarithm epsilon prime equals the logarithm epsilon prime of a. This is a of log epsilon a times t. And so this actually, if you want a sub-exercise, just by the definition of our formula of logarithm. So in other words, the summarize. The line Zp t in the maximal ideal will be drawn is independent of the choice of uniformiser. Is intrinsic, in other words. independent of the choice of epsilon and making a choice of Zp basis of this line is the same as making a choice of E. Also, choosing E is equivalent to a choice of a Zp basis for Zp1, which defined to be as a Galois representation, worst limit of mu p and k bar. P nth roots of unity of k bar form a group called mu p, and there is a transition map modulo raising to power p. And the action of G into this element T is given by, so G of T by G acting on the former power series and preserve the coefficient, and finally acting on the Hessian lift of epsilon, and so this is by the action acting inward, and this is hence Hessian lift of epsilon to the power chi g. So this element is this W bar, so the Galois action is component wisely, and so it's acting on this E. With acting on this E, this is still in R, acting still component wisely actually, but we summarize to this. And so finally chi g of log E, very precise. So good thing is this element, it's very easy to describe its Galois action. Where chi is the cyclotonic vector. And so Zpt is a canonical copy of Zp1 as GK stable line inside p-dram plus. Mark 2. We can also write fill I p-dram using t power, because this is again already a new generator of the maximal ideal. So this is not new definition, just different way to write the filtration or using different generator. Let's simply write a twist I. And so the fractional ideal of B-drum plus is also the same as just invert t. Then what do we have? The graded ring associated to B-drum is now, by definition, graded means graded piece of B-drum. And the integer as index. So this is the filtration I to run over filtration I plus 1 to run for I in Z. And so this is I in Z drum plus twist times t to the power I, but it's also the same as twisting by I. Let me write this. But if you write it differently, twist I, this is twist I, and you could keep one t and write the left one with twist I. The reason I do this is because then as ring and ideal, the quotient gives you the residue field, which is CK. Should we be careful with this? Oh, this is totally fine. Which means some part of the power of I gives you serves as Galois action. Some part of it serves as element of the module. Do you know what I'm saying? Yes. Yeah, I mean, it's okay if you don't want. This is the same as this, right? Just no, wait. I'm a little lost. Here. I'm a little lost. I'm not sure. Is this legal? I mean, if you're thinking of this, p times Zp quotient p to the power n plus 1 Zp, you will finally see this is isomorphic to Zp quotient by p. And in some sense, it's telling you this is isomorphic to Ck, right? Yeah. The problem is if you do this, it's still true as a module, but this is isomorphism as Jk equivalent. You keep record of the Galois action. So the Galois action here is exactly because if you take element here, let's say we take element here, x times ti bar, acting g on it, by definition it is gx ti and then cyclotomic of j to the power I, and then take bar. Right. Here's one more problem, which is the definition of the filtration bit run. Let me have a check. Beat the ROM. Filtration is it t to the power I times beta ROM plus or t to the power I times beta ROM? So beta ROM is already filled. And so if you write it as beta ROM times t, then this makes no sense. So here's a typo. It should be beta ROM plus. Otherwise, this is just itself. Because t is invertible. This is the field. Right. And so come back here. So for example, let's say this. When you say beta ROM plus times t equals beta ROM plus 1, what do you mean? You mean this is isomorphism as you mean this is JK equivalent of free BDR plus modules. I think that's what is meant by this equality here. In that sense, so this is obviously true as just a beta ROM. Plus modules. I have no problem with that. GQ are an isomorphism free beta ROM module. This is okay.